Now we're into solving linear quadratic systems. There are three possibilities. So you're used to solving two lines and then trying to find out where they intersect. Now what happens if we have a quadratic and a line? So this is a circle. Hopefully you remember that a circle with center 0, 0 has this equation. Is x squared plus y squared equals r squared. And then a circle, circle with center hk has this equation, x minus h squared plus y minus k squared equals r squared. Right? Just a little bit of review from grade 10. Okay, when we're trying to find the solutions of a quadratic and a linear equation, there's three possibilities. This is the case of no point of intersection. This is the case of 2 points of intersection. And this is the case of 1 point of intersection. All right, so here we go. Okay, equation of a circle with center 0, 0 and radius r is x squared plus y squared equals r squared. Oh, I had them down here. So first of all, we're going to solve by graphing, and then we're going to solve algebraically. Graphing and algebraically. So, can you tell me what is the center of this circle? Center of this circle is what? Nobody? Well, the center is hk, so it's minus 1 comma minus 1. Can anybody tell me what the radius is? Square root of 16 equals 4, right? Okay, so I better get a ruler ready. So, -1, -1. And the radius is 4, so we will count 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And 1, 2, 3, 4. So our circle is about there. Something like that. We just draw it the best we can. Okay, and our line, well, the y-intercept is 2. We'll just label our axes. Just assume that each square is a 1 by 1 square. So here, the y-intercept is 2. Okay, hold it. 1, 2. And the slope is -1. So for every 1 it goes down 1, over 1, down 1, over 1, down 1, over 1. And if you go up this way, it's over 1 up, over 1 up, over 1 up. So let's just draw these two, just join these points up, and then we'll have our line. So notice they appear to cross here and here. We have two solutions. We have this point 3, -1, and we have this point -1, 3. Good? Let's try this guy. Well, we have a parabola. Notice the vertex here is 0, -5, right? So 0, here's x. Oh, sorry. That's y. This is x. 0, -5, 1, 2, 3, 4, 5. The y-intercept is, no. Well, the y-intercept is -5. We need to find another point. Why don't we plug in 2? Another point on this graph. Like obviously, since our vertex is there, The y-axis is the axis of symmetry. So we need some other points. When x is 1, what would y be? Well, 2 times 1 is, that would be minus 3. So 1, 1, 2, 3. When x is 2, this would be positive 3. 1, 2, 1, 2, 3. We can get corresponding points by reflecting over the axis of symmetry. So there we go. Here we have our graph of our parabola. It's as good as it can get, right? So, you know what I forgot to do? I forgot to label our graphs. It's a good idea to label as much as possible. And this is y equals minus x plus 2. Alright, so let's draw the line. Y-intercept minus 1. Slope is negative 2. For every 1 it goes over, it goes down 2. 1 over, down 2. 1 over, down 2. This is 1 this way up 2, 1 this way up 2, and this way up 2. So we can graph this. So this is y equals 2x squared minus 5. This is y equals minus 2x minus 1. And you can see that there's 2 points of intersection. So the solution is 1 minus 3. And this is negative 2, 3. Can I answer any questions? May I answer? Yes. And then write an agent, whatever they call. Yeah, so you could just say 1, 1, 2, 2. Sure, that's perfectly acceptable. Okay, let's do it algebraically. Any other questions about solving by graphing? Okay, so these are the steps. Solve the linear equation for one of the variables. Well, this guy solved, that guy solved that night. That's nice. Then we're going to sub it into the quadratic equation. So wherever there's y, we're going to replace that y with x plus 5. Similarly here, wherever there's a y, we're going to replace it by 3x minus 4. We'll solve the quadratic equations, and then we sub all the values obtained in 3 into the linear. So notice, you start with the linear, you end with the linear. If you do that, you'll minimize your mistakes, right? You will minimize your mistakes if you do that. Okay, so I'm going to call this number 1 and number 2. So we'll sub it in. We'll sub 1 into 2. This kind of thing is important for your communication marks. So we have x squared plus x plus 5 minus 2 squared, right? Wherever there's a y, I replaced it with x plus 5 equals 65. So x squared plus x plus 3 squared equals 65. So now let's FOIL, and then we'll collect like terms. We'll subtract 65 because we need one side to be 0. So this is 2x squared plus 6x minus 56. So we make our lives a lot easier if we can divide everything by a common factor. So notice that's divisible by 2, that's divisible by 2, that's divisible by 2, that's divisible by 2. So you have x squared plus 3x minus 28 equals 0. So that's a lot easier to work with. This is so much easier to work with than this. So make your life easier if you can divide things out on both sides by the same factor. Go for it. Okay, so let's see. This is the only way we can get x squared is if you put x and x. Now this is negative 28. That looks like 4 and 7. The difference between 4 and 7 is 3. So I'm going to put plus 7 minus 4. And let's just check. X times x is x squared. Minus 4x plus 7x is 3x. 7 times negative 4. Always be checking your work. So x equals minus 7 or x equals 4. So if x equals minus 7, now we sub in the linear, right? You start with the linear, you end with the linear. Y equals negative 7 plus 5, and that equals negative 2. If x equals 4, y equals 4 plus 5, and that equals 9. So you'll get a half mark there and a half mark there. However, if you want the last mark, you have to say the solutions are negative 7, negative 2, and 4, 9. May I explain anything better? Let's try, you have to sign in, okay? Sorry, it's just our guidelines. Okay, here's 1, here's 2. Let's just, wherever there's a y, we'll just say 1 equals 2. Or you can say sub 2 into 1, that's okay too. So 3x minus 4 equals 1/3 x squared plus 2 over 3. How are we going to deal with that? What should we do first? Get rid of the denominators, right? So multiply both sides by 3. So you have 9x minus 12 equals x squared plus 2. We'll set one side to 0. 0 equals x squared minus 9x plus 14. Okay, so let's see. The only way we can get x squared is an x and an x. Well, this looks like 2 and 7. 2 and 7 add up to 9, but we need a negative 9. So we'll put negative 2, negative 7. Okay, so x equals 2 or x equals 7. If x equals 2, y equals 3 times 2 minus 4 equals 2. If x equals 7, y equals 3 times 7 minus 2, and that equals 19. No, hold it. Minus 4. My mistake. You're right. Thank you so much. I really appreciate it when you help me out. So that should be 17, right? So the solutions are Well, negative 2, no, positive 2, and 7 comma 17. Anything you need me to go over? Determine if the quadratic function will intersect once, twice, or not at all with the given linear function. What do you think we're going to need to be using for this? The discriminant, right? So we need the discriminant. Remember, if b squared minus 4ac is greater than 0, you have two solutions. If b squared minus 4ac is two different solutions, right? Different, sorry, that's squished, is equal to 0, you have two equal solutions. And if b squared minus 4ac is less than 0, you have no real solutions. So 0. So they just do not cross. So if b squared minus 4ac is less than 0, then you have a situation that looks something like this, right? The b squared minus 4ac would be less than 0. B squared minus 4ac is greater than 0. B squared minus 4ac equals 0. So let's do it. We will equate the two functions and simplify. So we'll just go f at x equals g of x. We're just going to equate them. So we have 2x minus 8 equals 3x squared plus 12x plus 14. So 0 equals 3x squared plus 10x plus 8 plus 14 is 22. So, if they're not asking us for the solution, they just want to know the nature of the solution. So let's just calculate b squared minus 4ac. That's 100 minus 4 times 3 times 22, and that equals, if you trust me, it's negative 164. This is less than 0. Therefore, there is no solution the quadratic and the line, the quadratic and the line do not intersect. No solution. Determine, here's one. Determine the value of the y-intercept of the line with the slope of negative 2 that is tangent. Now, this is an example of tangency, where the line hits the graph exactly once, and here b squared minus 4ac would equal 0. Right? Here in this, when you're solving this system of equations, b squared minus 4ac would equal 0. Determine the value of the y-intercept of a line with the slope of minus 2 that is tangent to the curve with this equation. So, let the linear equation be y equals minus 2x plus k. So, this is what we're solving for. we're trying to find the value of the y-intercept. This here is the k is the y-intercept, right? K is the y-intercept of the line. So that's what we want to solve for. So we have this line, we have this line. Let's equate them. Equate the two equations. We get minus 2x plus k equals 3x squared minus 4x plus 1. Set one side to 0. That's going to be 3x squared minus 4x plus 2x minus 2x plus 1 minus k. So here you know a equals 3, b equals minus 2, c equals 1 minus k. So if we want to find out what k is, what we're going to do is, we know that if it's tangent, it hits the quadratic, the line hits the quadratic just once. B squared minus 4ac is equal to 0. So negative 2 squared minus 4 times 3 times 1 minus k equals 0. So 4 minus 12 times 1 minus k equals 0. 4 minus 12 plus 12k equals 0. A lot of math here, right? Minus 8 plus 12k equals 0. We'll add 8 to both sides. So k equals 8 over 12. Simplify. K equals 2 over 3. So the y-intercept is 2 over 3. Fair enough? Can I explain anything?